Graphing a rational expression or a rational equation has a couple of unique features to that. And so I want to just kind of show you some of the ideas when I want to graph a function similar to 1 over x squared. A couple things to note: it's an even function. My x term is to the square, provides an even idea. It's an even function, so it's symmetrical above or about the y-axis. So whatever I graph on this side, it's going to be reflected over on the other side. A couple other ideas I can look at is if I evaluate it at 0, I notice then that I don't have an answer. It crashes. So this tells me then that there's no value, or x equals 0 is excluded from the domain. So I know that my graph will never cross the y-axis at the point x equals 0. Additionally, if I set my function equal to 0, I can't find a time when that is the case as well. So there's no solutions. So my graph will start to carry on a look where I'll have this field where it doesn't cross the x-axis or crosses the y-axis. So that's one side of it, and since it's symmetrical, and I found those other points by testing some values in there. So I start to get an idea what its in behavior is. So for example, if I wanted to find out what's the value at 10, would be 100. So I know that the point 10 and 100 is on my graph. So I'll go up 10 and over out to here to 100, and there's a point. And I can test some other points as well, and then likewise, since it's symmetrical, I'll have the corresponding point on the other side. So that's a little bit about what this particular graph will generally look like. And once we have an idea what this graph looks like, then we can identify other similar rational expressions as well and have an idea what its graph as well looks like.